You can download the answer in the video for free, link in the description. For a custom weight random generation system that is specifically useful for item drop, go to the scene that you want to have the random item drops. Here I have my slime enemy, which has a button attached, so when I click, the slime dies. Inside the script, add two export variables. Item drop is an array that contains the items that the slime can drop, and packed scene means that each array entry is a scene file. Alternatively, you can choose to have the array values be equal to any other type, including a custom resource, float, integer, or string. But for the item drops, I recommend using a packed scene. Item drop chances is an array of a float, which is the chance that we get each entry in the item drop, as we will sync the first entry of the item drop chances with the first entry of the item drop array, and so on. This is needed to add the weight to the randomness, so that some items are more likely to drop than others. We will then add two custom functions. Fixed item drop arrays will make sure that the number of entries in each array is the same, to avoid errors of grabbing an entry that doesn't exist in one of the arrays, and drop item will hold all the logic for the weighted random generation system. Inside the button press signal function, which for your game could be a death function or wherever you want to initiate the item drop, we check if the size of the item drop array is more than 0, meaning that there are items to choose to drop. Then we fix the item drop arrays, then run the drop item logic, and finally queue free to remove the enemy from the scene. Inside the fixed item drop arrays, we check if item drop chances has less entries than the item drop. If so, we use resize on item drop chances, which simply adds extra entries to ensure that the array is the same size as the item drop array. We also do this for the item drop array in the case that it has less entries than the item drop chances array. We must do this because if one of the arrays has more entries than the other, and we try to grab an array entry that doesn't exist, then Godot will error and may cause a crash. Additionally, resize will add empty entries based on the type of the array. Item drop will add null entries, and item drop chances will add entries with a value of 0.0. If you would like, you can also add a for loop that goes through the item drop chances array, then sets the minimum value of the array to change that 0.0 that may have been added so that there is a chance of the correlated item appearing. Additionally, you can also add a loop for the item drop array as well, although this is up to you based on your game. Inside the drop item function, we create a variable that holds the total weight, then we iterate through each entry inside the item drop chances array and add each value to the total weight variable. This is so we know the range for the random number to pick. We then add two more variables. Rand is equal to the random number that we will use to grab the item to drop. An updated drop value will be used to keep track of the true value of each entry in the item drop chances array. As for this system to work, we need to treat each entry as if it were equal to its set value plus all the values of the previous entries, because otherwise the total weight would far exceed what is possible in the entry array. Additionally, this also ensures that the order of the items in the array doesn't alter the chances of that item being chosen to drop. Finally, we iterate through each entry in the item drop chances array. We then add that entry's value to the updated drop value so that the weighed random system works properly. Then if rand is less than or equal to the updated drop value, meaning that this is an item that we have landed on, then we check if the item scene from item drop is null. If so, we use return to skip all the code below and stop the function. Otherwise, we grab the item scene and use instantiate to create a unique copy of it. We then set the global position appropriately, and we add it to the scene as a child of the topmost node, and we use break to stop the loop from continuing. Get tree.currentScene will grab the topmost node in the current scene that is loaded. Then we use call deferred to add the item scene as a child at the end of the current frame. This is to avoid an error involving queue free, as we are removing this scene after running this. Now, when the scene is added to your game, on the right select both arrays, then add an entry to each one. You could then add the scene for the item that you want to drop, and then set the chance appropriately. When you add more scenes, it is recommended to keep each array at the same amount of size. Additionally, because this is a weighted system, having one for each of the items means that there's a 50% chance of either item being placed. Because this is weighted, we can change the numbers to give certain items a higher chance of dropping than others. Now you have a weighted item drop system that you can add to any of your games and improve further. Don't forget that you can check out the project files linked in the description.